Have you ever wondered how we measure something as seemingly intangible as smoke or visibility? The answer lies in devices called transmissometers. A transmissometer, at its core, is an instrument that measures the amount of light that passes through a medium. In this video, we'll explore how they work and how they are used, especially for measuring smoke, and to help us understand, we'll be using my own 3.3 meter longbow transmissometer. The fundamental principle behind a transmissometer is light attenuation. Light attenuation is the reduction in the intensity of a light beam as it travels through a medium. This happens because particles in the medium, whether they're smoke, dust, or even water droplets, can absorb light or scatter it away from its original path. A transmissometer consists of a light source, which emits a beam of light, a receiver, which measures the intensity of the light, and the path between them, which is the medium being measured. The key concept here is that the clearer the medium, the more light reaches the receiver. Conversely, the more opaque the medium, the less light reaches the receiver. This relationship is often described mathematically by the beer-lambert law, which states that the intensity of the transmitted light decreases exponentially with the concentration of the attenuating substance and the length of the path. In simpler terms, the more stuff in the way means less light gets through. This is my 3.3 meter longbow transmissometer. I built this to get a better understanding of how these devices work and how to demonstrate their principles effectively. It consists of the light source, a high-intensity LED, and lens, which emits a focused beam of light, and the receiver, a highly sensitive photodiode, which measures the intensity of light received. The structure is designed for stability and to maintain a constant path length. One of the biggest challenges was ensuring precise alignment between the light source and the receiver. Even a small misalignment can significantly affect the readings. I also had to minimize the effects of stray light, which would interfere with the measurement. The 3.3 meter path length was chosen. It is 20 times longer than the Octorings that I use. It is the distances involved in real-world visibility measurements, or to increase the sensitivity of the measurement. If I want to measure fog and rain, this outdoor longbow should work. When it comes to measuring smoke, transmissometers are invaluable tools. Smoke composed of tiny particles is very effective at attenuating light. The denser the smoke, the more light is blocked. By measuring the amount of light that passes through a column of smoke, a transmissometer can determine the smoke density or opacity. Opacity in this context is a measure of how much light is blocked by the smoke. It is calculated as 1 minus the transmittance. The measurement is critical in many applications, for example, environmental monitoring. Transmissometers are used to measure air quality and ensure compliance with emission regulations. In industrial settings, they help monitor smoke from stacks and prevent pollution. They are also vital in fire detection and control systems, and even in metrology for determining visibility. This is the most descriptive chart. This is incident light received by the sensor. I misspelled incident light in one of the first 5 hours. It rained hard, so we get a reduction in light. The base light is about 92 lux. The next day, the sun came out, and so we get a nice slope up as the sun brightens the background. And I'm working on that with baffles, and that's the sun comes around just about every day. So I'm working on it. However, you can clearly see, or I can see, the difference between rain obstructing the lens or the path and the sun. Transmissometers have a wide range of applications. At airports, they're used to measure runway visual range, or RVR. which is crucial for safe landings, especially in low visibility conditions. They are also used to measure the opacity of vehicle exhaust, ensuring that the vehicles meet emission standards. In forestry, they can help monitor smoke plumes from wildfires, aiding in firefighting efforts. Industries use them to monitor emissions from smokestacks, ensuring compliance with environmental regulations. And in research, they play a role in atmospheric science and climate studies. Transmissometers offer several advantages. They provide a direct measurement of light transmission, which translates to accurate readings, especially in low visibility conditions. They are also known for their reliability. However, they do have limitations. They can be relatively expensive, and they require regular maintenance, including alignment and calibration to ensure accuracy. They can also be sensitive to environmental factors like fog and rain, which can affect the measurements. Additionally, the measurement is dependent on the path length. Longer paths are more sensitive to attenuation. In summary, transmissometers are essential tools for measuring light transmission and consequently smoke density and visibility. They provide valuable data in a wide range of applications, from ensuring safe air travel to protecting our environment. And as we have seen from this 3.3 meter long bow transmissometer, the basic principle is quite straightforward, even if the engineering can be complex. I hope this video has given you a better understanding of how these important devices work, and if you have any questions or comments, please leave them below. Thanks for watching.